Hello everyone, I am Zeenat Bazira, Assistant Professor, Department of Physics, Sadaqatullah Appa College. Welcome to my video, where we simplify science and make learning fun. Now we are diving into mechanics, a fascinating branch of physics that explains how and why the objects move. Have you ever wondered what happens when you push, pull or throw something? Forces are everywhere. They make objects move, speed up, slow down, stop, or even change their shapes and directions. Sounds interesting, right? Let's get started. Have you ever wondered why a ball falls downwards when you drop it? Or why a car moves forward when you press the accelerator? These everyday actions are explained by mechanics. Now see what is mechanics. Mechanics is a branch of physics that deals with the motion of objects and the forces acting on them. It is the foundation of many technological advancements and forms the basis of engineering and applied sciences. Types of mechanics. Now let's break mechanics into four main types. Number 1, classical mechanics. 2, quantum mechanics. 3, relativistic mechanics, and the 4th, statistical mechanics. First up, we have classical mechanics. Classical mechanics is also known as Newtonian mechanics. It is the study of objects at macroscopic scales. It deals with the concepts like velocity, acceleration, force, and energy based on Newton's law of motion. This type of mechanics is applicable to objects moving at speeds much slower than the speed of light. Now see the example, the swinging pendulum. It is a simple example of classical mechanics. Gravity pulls it back, converting potential energy to kinetic energy as it swings, perfectly demonstrating motion and energy at work. Next, we step into microscopic world with the quantum mechanics. Quantum mechanics, on the other hand, describes the behavior of particles at microscopic scales, such as atoms and subatomic particles. It introduces concepts like wave-particle duality and uncertainty, which are essential to modern physics and technology. Example, in quantum mechanics, electrons do not orbit the nucleus like planet. Instead, they exist in a cloud of probability, behaving as both particles and waves simultaneously. Next, relativistic mechanics. Relativistic mechanics comes into play when objects move at speeds close to the speed of light. Introduced by Einstein. This type of mechanics incorporates the theory of relativity, explaining how time and space behave differently under high speed condition. Example, astronauts traveling close to the speed of light would age much slower compared to people on Earth. Mind blowing, isn't it? Finally, we have statistical mechanics. The branch combines the ideas of classical and quantum mechanics with statistics to explain the behavior of systems with a large number of particles like gases or liquids. For example, it explains how countless gas molecules in motion create measurable properties like pressure, temperature, and energy through probability and averages. Recap. Classical mechanics explains the motion of everyday objects. Quantum mechanics deals with the strange behavior of tiny particles. Relativistic mechanics covers objects moving at near light speeds. Statistical mechanics connects particles and large systems through probability. Mechanics truly is the key to understanding the physical world from the smallest particle to the vast universe. Thank you for watching.